All right, experiment number 2. For the experiment number 2, what you will get? You will get an Arduino. You will get few breadboards, actually 2 breadboards, so big one and the small one. You will get obviously tons of jumper cables. You will get the Rgb sensor. You will see this Rgb sensor. You will see different connections. And this is the Rgb sensor. Actually, we will use a new Rgb sensor that we still have to solder. And this doesn't work, of course. Better. You will get this Rgb sensor. The things you need to pay attention here is that this one is your sensor, and this one, it's a white LED, and they usually use it for reflecting the color. So you want to deactivate this LED when you do your experiment, because what we are going to look for is transmission and not reflection. So when you are designing something, remember that this one in the center is your Rgb sensor. This is the LED. We will solder the connection, so you don't have to. So we will solder the pins, and this will look like something like this. Then you make the connection and hopefully make it work. So we have our Arduino, Rgb sensor, and naturally you will get quite some LEDs. The LEDs, you need to check which one do you want to use for which experiment. And now I'm going to tell you which experiment we are going to do. So, what we are going to do? Part 1. Colorimetric detection. And for colorimetric detection, we are going to use a pH dice. Then we are going to use fluorimetric detection, so fluorescent detection using fluorescein. For colorimetric detection, you want to have the LED, you will get your cuvette, and you want to have your sensor from this other side. So this one is your Rgb sensor. For fluorimetric detection is the same, so you lose LED, your cuvette, and then your detection is here because it's at 90 degrees because we want to check the detection, the fluorescence. And practically this is what I want you to do. And again, remember that at the end, what I want, it's a calibration curve. So where you will have the pH, and here you decide what to put. Both for pH and for fluorescence. This will be divided in 3 parts. So in the first part, and let's say the first week or the first day of the week, you will do arts and crafts. So use scotch tape, use duct tape, use wherever it's in your place for putting the sensor, the LED, and connecting the Arduino, and check how they work together. Both in both direction, check which LED you want to use, check which distance you want to use, check which power you want to give to the LED, the distance of the sensor, check a little bit how the system works. And this is why we're going to arts and crafts the first time. The second part is design and 3D print. Now that you know more or less the dimension that you want to achieve, then you can design and you can 3D print. For example, this one are from last year. This is one, this is another one. design wherever you want. The only things I'm asking you for the design, those ones are all done by students last year. They are very different. They work always in the same way, but it depends on the distance you want to use, which kind of light you want to remove from the environment, and so on. So this one you are free to do practically wherever you want if you have a good idea in mind. The only thing I'm asking for the 3D printing part, send me one STL for the print that you want to make. Don't put multiple things together and send me this STL, but send me one STL per things that I need to print. This is one. The second one, print only the flow cell, because this year I have to print 29 or more of those things, and time is it's quite a lot for printing. If you want to print the Arduino case inside this, so try to print only the cell that you want to use. And the third thing is measure twice and print once. So you will think that this one is 1 centimeter, but it's actually 1 centimeter the internal part. The external part is bigger than 1 centimeter, so measure the cuvette and print it a little bit bigger, so that you know that it will move a little bit, but it will fit. Don't print it too small that it doesn't fit anymore. Those are the things that I'm asking you for the STL. Why pH and why fluorescence? Now, before you say,
so boring,
you need to realize that this pH dice is used for the detection of COVID. So this Phenol Red is used for the one-step detection of COVID. So there is an enzyme that translates RNA to DNA, and then the LAMP enzyme will amplify this DNA. For the detection of this DNA, you can use two things. So if the LAMP works, the pH will decrease. So you move from red or purple violet to yellow, and this is your detection. But it's not only between red and yellow, there is a lot of orange in between, and it's really difficult by eye to set a threshold. This is why I'm asking you, can we set up a threshold by using the Arduino and check which color it is? And the second way of detecting the amplification of DNA, so if a COVID test is positive or negative, it's by using a fluorescent dye. So this fluorescent dye intercalates in the DNA and it gets more green fluorescent. And this is why I'm asking you, can you check what's the limit of detection of fluorescein, because it's a dye that is similar to the one used in COVID test. So it looks simple, it looks boring because it's just a pH, but how they use those dyes, it's super important nowadays, and actually in general. And here we come to the third point. Once this one works, so once point 1 and point 2 work, you know how to measure in a normal cuvette, you have your beautiful design. The third point is, can we detect it in a small vial, in a small Eppendorf used for the COVID test? Can we use this method, both colorimetric and fluorescence, for checking the COVID Eppendorf? And actually, this is the real challenge for you, because the COVID test or the COVID Eppendorf that they are using are extremely small. So they are 200 microliters or 100 microliters, and what they are measuring, it's 25 microliters. So this is now your detection part. You want to detect a color change in 25 or 50 microliters. But this is the size that now you're going to detect. Is it this even possible? It's not squared anymore, it's not big anymore, it's small, and the volume is really low. Can we do it? I don't know, and this is why we are doing this experiment.